In this video, we'll be going over examples for the lesson on graphing quadratic functions. To start off with, we're given a function, and we have to find the quadratic term, the axis of symmetry, and its min or max. To start off with, the quadratic term is just the term with the x squared in it, so it's 3x squared. Note that the answer here is not 3, because 3 alone isn't a quadratic term. 3 alone is a constant term. Just like how 3x isn't quadratic or constant, it's linear. So the answer is 3x squared. To find the axis of symmetry, we have to start by finding the vertex. You may also note that finding the vertex will also help us with finding the min and max, whatever it will be. So the x value for the vertex is negative b over 2a. Well, in this case, b is 6, and a is 3, so 2 times a is 6. So x is negative 1. That means our axis of symmetry here is that x equals negative 1. Now for the min or max, well, is it a min or is it a max? A is equal to 3, and that 3 is a positive number. And if a is positive, that means your y values are going to get really, really big. So you're going to have a min, because it can get as big as you want it to, but not as small as you want it to. So we know it's a min. The question is, how low does it go? Well, we know the vertex is when the x-coordinate is negative 1. And we know that a vertex is the location of the max or min. So, to find this out, all we have to do is say, how does the function act at the vertex? This tells us the y value at our axis of symmetry, our y value at the vertex. So if we evaluate our function at negative 1, we have 3 times negative 1 squared plus 6 times negative 1 minus 4. Well, negative 1 squared is just 1, so we've got a 3 here, and 6 times negative 1 is negative 6. So this plus 6 times negative 1 is going to be minus 6. Then I've got a minus 4, and that's negative 7. So our minimum value for this quadratic is negative 7. For number 2, again, we're given a function, and we have to find the quadratic term, axis of symmetry, and min or max. To begin with, the quadratic term is just the term with x squared. In this case, there's no coefficient, it's just x squared. And again, for the axis of symmetry, we have to find the vertex. Well, the vertex we know is negative b over 2a for the x-coordinate. But what is b in this case? Well, I can rewrite this as 1x squared plus 0x minus 4. In that case, b is just 0. So our x-coordinate for the vertex is 0, which means our axis of symmetry is when x is equal to 0. So now that we found the x-coordinate of the vertex, to find the min or max, we just evaluate the function at the x-coordinate of the vertex, which is just going to be minus 4. Now, to determine whether it is a min or a max, well, the a value in this case is just 1, because the coefficient of x squared is just 1, it's just x squared. And this is a positive number. And if a is positive, we have a min. For number 3, we have to determine which graphs best represent the function y is negative x squared plus 7x plus 8. So, let's start by finding the vertex. The vertex x component is negative b over 2a, which is negative 7 over 2 negative 1, which is negative 7 over negative 2, or 7 halves. So immediately I know that a could not be correct, because a has some different x-coordinate for its vertex. We should also note whether this quadratic has a maximum or a minimum. So our a in this case is negative 1. And if a is negative 1, and it's less than 0, which means I have a max. So I can go as far negative as I want, but there is a maximum value that y never exceeds. Well, in this case, I know the answer, because for the cases of b and d, it's a min. C is the only one which has a max, and that is the correct answer.